Is what? A row of elements arranged is called. A rule of element arranged is called. It could have been okay. A rule of element, just like that rule, it should be taken to be what? Horizontal. I mean, that's what I say. It's called a what? A period. Then the period number is n. This at the end, that's n. I would just say this is n. Then the value of n starts from what? 1 to what? 7. Okay, and then the elements are aligned vertically. You say if it's vertical, that means it's a column, which is also called what? Group, with other elements in that different rule. If they share the same outer electronic configuration, that means they belong to the same group because they have the same valence what? Electron. So element in the same group appears to have the same valence electron. So that means all the elements in this particular group, 7, all have valence electron of what? 7. That means they will all have 7 outermost shell electron. Okay. Electronic configuration of hydrogen and helium are unusual. I think I said it before. Very unusual. Because if you assign this as group 8, this does not have up to 8 valence electron. Are you with me now? So that other element down here have 8 valence electrons. So they are unusual. And if you assign hydrogen to be in this particular group, it doesn't have the same property with this because all these are metals, but this one is what? Non-metal. So as a non-metal, it should have been placed in group what? 7. Okay, so because the group must have similarities in physical and chemical properties with other members of the group. So all members of a group must share the same what? Properties. Okay, helium is placed in group 0 on this basis. So on the basis of being that at least it has achieved maximum number of electrons in that shell, it is placed in group 0, which we now call group 0. This 8 now. It's now referred to as what? Group what? 0. That is any element whose outermost shell is complete belong here. Even if it is duplet or what? Octet. Duplet in the case of helium. Is 2 states. That is K shell can only hold how many electrons? 2 electrons. So that means helium achieved that. So that's why it's placed here on that basis. Okay, let's look at blocks. Take it down. Blocks of the periodic table. From there, you have 4 blocks. Okay, 4 blocks. That is, we have the S block. Okay, we have the P block. We have the D block. We have the D block, and then we have the F block. Looking at this table here, the S block elements is what? Which group is referred as S block? Which group is the S block here? Group 1 and 2. Not just group 1. In fact, it is any element whose last subshell is either NS1 or NS what? 2. This N can mean is 1S. This N can mean 1S1 as in hydrogen. Okay, it can mean 1S2, 2S1 as in lithium. It can mean 1S2, 2S2, 2P6, 3S1 as in what? Sodium. If you look at the trend here, you will find out that hydrogen, lithium, and sodium appears to have what? How many electrons in their last shell? 1s. Are you there? So for the fact that the last shell is S block, electron, the last electron appears to be in that S block. Are you there? Element whose last subshell appears to be S, and there are electrons, either one, maximum of electron in that shell should be what? 2. So that's why those here will be ns what 2. Just like we have something like beryllium 4 have 1s2 2s2 is also s block element. So all elements whose last subshell appears to be s, and there are either 1 electron in that shell or 2 electrons, are s block elements. So they are alkali metals and alkaline what? Earth metals. The trivial name of group 1, they are the alkali metals. These ones are the what? Alkaline earth metals. So the alkali metals alongside the alkaline earth metals are the s block elements. Are you with me now? So these 2 blocks are s block. The whole of this block from here to here or here, from here, I don't know how I'm going to get it, from here are all what? P block elements. Are P block elements. Then, now, okay, let's look at example. Let's look at chlorine. Now, before chlorine, let's get this. Let's get these points clear. Just like the electronic configuration of KLO, those shells. Okay. Now, please take note that these are shells, but these are what? Subshell, shell, subshell. What this sub means, these are the region of the shell where you have possibility of seeing electron. They are just like a smaller aspect of a shell. Just like if you look at a K shell, let's assume this to be a K shell now. This shell is very close to the nucleus. Around this region, there are some other shells here, which is not that visible. That shell is the what? The subshells. Now, this K as a shell has only one subshell, which is what? 1s. As simple as that. What this one signifies is shell. Is shell. This one signifies what? Shell. What is this S signifying? Subshell, correct. Subshell, smaller shell. Then if you have one here, what is it signifying? Electron. Just say electron. And this will now be the electronic configuration of what? Hydrogen. Because that particular element does have one electron. This represents hydrogen. Are you with me now? So I can say that 1s is equals to, or I can say that K shell is equals to what? 1s. Look at this. K, the value of shell, the value of energy level here is what? 1. This is 2, this is 3, this is what? 4. So that is this 1. So it has just one subshell. Then L, how many subshells? 2 subshells. Name the subshells. 2s, because that's the value of L is 2, and the what? 2 what? P. For M shell, what is the value of M? 3. So how many subshells? 3. Name them. 3s, 3p, and 3d. What about N shell? How many? 4. What are they? 4s, 4p, 4d, 4f. The maximum number of electrons in this shell is what? 2, isn't it? Here's what? 8, isn't it? Here's what? 18. Here's what? 32. Maximum number of electron in S shell is how many? 2. Use this formula now. Simple. Just like the value of this is 0. This is 1. This is what? 2. This is what? 3. Let this shell 1, 2, 3, 4, they are L. The value of L for S is 0, P is 1, D is 2, F is what? 3. So if you want to know number of orbital, S orbital, I will use this formula again, 2L plus 1, where L for S is 0. So if I import 0 here, 0 times 2. 0 is any number that I will multiply something to be 0. 0 plus 1. That means how many orbital are there in S? 1. S has 1 orbital. How many orbital are there in P? 1 times 2, 2 plus 1, 3. P has 3 orbitals. How many here? 5. How many here? So now that I know that for S subshell, I know the number of orbital is 1. This is what is it now? Like 0 times 2 plus 1 is 1. So how many electrons are here now? And now is this formula. How many electrons? 2. This will hold 2 electrons. If the orbital, like in P, appears to be 3, 3 times 2 is what? So how many would be here? 6. How many would be here? 2. Let's check if we reconcile. If it's equals to, this is 8. 2 plus 6 is what? 8. Let's see if this will be 18. How many will be here? 2 here, here. 10, isn't it? Check if it's 18. I think it's 18 now. Here, 2, here, 6, here, 10, here, 14. Check if it's 32. I guess it's 32. I guess. That is why. Supposing we have, okay, now look at this. Look at this. I have that the electronic configuration of sodium is 2, 8, 1. Remember now? That is K, L, and what? M. I can also say that this K is same thing as what? 1 as what? 2. This P, which is 8, is set as what? 2s2, 2p6. Remember, this is 3 energy, isn't it? Here is what? 3 as what? 1. Are you with me? Are you with me on this? Are you with me on this? And in fact, this is what has replaced this now. An element to this electronic configuration will belong to which group? I will now go to the last subshell. The last subshell is what? 3s. How many electrons are in that 3 subshell? 1. It belongs to group 1. Then period what? 3. And then what makes it an S block element? Because the last subshell is what? S.